Welcome back. In the previous lecture, we learned how to create Boolean masks using comparison operators. In this lecture, we will explore specialized np.where functions that aggregate these Boolean results or provide conditional element selection, giving you more robust control over your data filtering. 1. Aggregate Boolean Results. After creating a Boolean mask, you often need to summarize the result. The all function checks if every single element in the resulting Boolean array is true. The any function checks if at least one element is true. These methods are commonly chained directly onto the comparison operation itself. 2. Conditional Selection. The np.where function is NumPy's vectorized equivalent of a ternary conditional operator or an if-else statement. It takes three arguments: a condition, the value to insert if the condition is true, and the value to insert if the condition is false. Here, we replace values greater than 25 with the string high, and the rest with low. If you only pass the condition, np.where returns the indices of the elements that meet the condition. 3. Floating point tolerance. Due to the inherent nature of floating point arithmetic, checking exact equality between floating point numbers often fails unexpectedly. The np.isclose function solves this. It checks if two arrays or values are equal within a specified tolerance, which is the standard practice for comparing floating point numbers in scientific computing. Always use np.isclose instead of the double equal sign when dealing with floats. To summarize, these specialized functions give you complete control over conditional logic in large arrays. Next, we will discuss an important topic: copying arrays. Our next lecture 35.07, Copying Arrays. See you there.